Welcome to my presentation. In this presentation, we shall look at some vector operations in 3 dimensions. We'll look at some properties related to that, and then we will use those properties to solve some simple example problems. So, first property, we want to know how to find the magnitude of a vector. How to find the magnitude. Let me write this. Magnitude of vector. Magnitude of a vector. If A is a vector, and if the components of this vector are a1i plus a2j plus a3k, the magnitude is given as, we're going to draw 2 lines on either side that way, and then we're going to take the magnitudes and raise them to the power under the radical sign. A1 squared plus A2 squared plus A3 squared. This is 2. Okay, so that is the way we can find the magnitude. The second property is telling us that if we have 2 vectors, if A is a vector and if the components of those are a1i plus a2j, let me write this a little clearer. If this is a2j plus a3k, and then if we have another vector b, and if the components of those are b1i plus b2j plus b3k, then the following properties are true. Then vector A plus vector B, we can write this as follows. Vector A plus vector B is going to be a1i plus a2j plus a3k plus b1i plus b2j plus b3k. Right? Since we know that I dot I is equal to j dot j is equal to k dot k, that is equal to 1, and then the rest of the properties I dot j or j dot k or k dot I are equal to 0, we can then simplify this as follows. This is going to equal to a1 plus b1i, a1 plus b1i, like that, plus a2 plus b2j, like that, plus a3 plus b3k, and then the rest of the elements will drop out because the I dot j or j dot k or k dot I, they are going to go to 0, and therefore those will cancel out. Those will go to 0. This is what is called the addition property of these 2 vectors in R3 spaces. Okay, and the next property here we want to talk about is this. So if A is a vector which has a1i, a2j, and a3k, and if B is another vector, b1i, b2j, and b3k, then we can find the difference of 2 vectors. The way to do that is as follows. Vector A minus vector B is going to be equal to, we can write this as a1i plus a2j plus a3k minus b1i plus b2j plus b3k, and therefore since we've already seen these properties hold good here as well, and therefore we can come back here and say I dot I will be, we can write this one as a1 minus b1i this is I, plus A2 minus B2J plus A3 minus B3K. Therefore, this is what is called the subtraction property of vectors. This is the subtraction property. And if we have A and B as two vectors, we can also show that any scalar quantity times a vector will be just the multiples of that scalar quantity. It is going to be that scalar quantity will be distributed to every one of the elements in that particular vector. So to illustrate that, if we have C as a scalar quantity, and if A is a vector which has components A1I plus A2J plus A3K, we can write this one out as the scalar quantity, the constant times A1I plus the constant times A2J plus the constant times A3K. That's the way we can show that property, and this property is called the scalar multiplication property. So we have seen how to do addition of two vectors, subtraction of two vectors, and a scalar multiplication of a vector. Let us also see some more properties in here, and then in this property, in this next property, we're going to see how we can do a scalar product or dot product. Let me write that. Scalar product, or sometimes this is also called as the dot product. Scalar product or the dot product. In here, once again, if we have two vectors, if A is a vector, and if the components of this vector are A1I plus A2J plus A3K, and if B is another vector, and if the components of these vectors are B1I plus B2J plus B3K, then the scalar product or the dot product is written as vector A dot vector B, and we can expand this as follows: A1I plus A2J plus A3K dot B1I plus B2J plus B3K, right? Therefore, according to the dot product, we know that I dot I is equal to 1, J dot J is equal to 1, and K dot K is equal to 1. And then also we know that I dot J is equal to 0, J dot K is equal to 0, and K dot I is equal to 0. So we're going to recognize that, and therefore once we recognize that, we can come back and then write this dot product, vector A dot vector B, as A1 B1 I dot I is going to be equal to 1, therefore we don't write that, plus A2 B2 J dot J will be equal to 1, so we don't write that, plus A3 B3 K dot K is equal to 1, so we don't write that, and then the rest of the elements, like for example A1I B2J, I dot J will be 0, I dot K will be 0, J dot I will be 0, J dot K will be 0, K dot I will be 0, K dot J will be 0, and therefore we did not write those elements down. So therefore the dot product, the scalar product or the dot product between two vectors can be written out as the product of the components of those particular corresponding corresponding components of those vectors. So that is the property. The next property we want to know is about the angle between two vectors. If we have vector A like that, if that is a vector A, and if we have another vector like that, which is vector B, we want to know what is the angle between these two vectors. How do we measure the angle between those two vectors? And the way to do that is as follows. The angle theta between non-zero vectors A and B are given to us as follows. Cosine theta is equal to vector A dot vector B divided by the magnitude of vector A times the magnitude of vector B. So that's the formula. It is very similar to the one which we have seen in vector operations in 2 dimensions, very similar to that. So these are some of the properties related to vector operations in 3 dimensions. We will use these properties to solve some example problems in my next presentation.